All right, in this video, we're going to be talking about point slope form. But before we do that, I want to do a quick review of the slope formula. The slope formula is what we use when we have 2 points. So here's a point, x1, y1. This is a little 1 here. And we say it's x1 because there's more than one. So this is the first one, this is the second one, this is the first y, this is the second y. The first x and y are a pair, the second x and y are a pair. And if I want to find the slope, I'm going to find the change in my y. So I'm going to take y2 minus y1, and I'm going to put that over x2 minus x1. And you'll see us use this in our example. Before we go on to that example, we're going to be looking at our point slope form today. The point slope form of an equation is y minus y1, so you can see that notation coming back, equals m times x minus x1. Again, you can see that notation returning. All right, our m here stands for slope. x1, y1 stands for any point on the line. Okay, so it could have been this one or the second one, as long as you keep them together. All right, let's look at an example of how you would take this information and write an equation. So we are going to write an equation in point slope form of a line that passes through 3, -1, and has a slope of -2. All right, so again, we're going to be using this point slope form. I'm going to identify my key parts. My slope is given to me in the problem, and my slope is -2. And then I want to identify what is my x1, y1, which is also given to me in this problem. And I can see that x1, y1 is going to be the point 3, -1. Just for clarity, I'm going to go ahead and label that this is x1 and y1. And now I can begin setting up my formula. Okay, I'm using my y minus y1 equals m times x minus x1, and I'm just going to match my parts. I know m is going to go in place of m. I've had both of those in purple. So now, rather than writing the letter m, I'm going to write what m is equal to, which is -2. And now I can start filling in portions of my equation that don't change. So I'm going to have x minus a value I'm not sure of yet. And I'm going to have y minus another value I'm not sure of. So I'm leaving the blanks that I'm going to fill in here. And now that I've done that, I need to identify what is my x1. Right? My x1 is 3. So I'm going to take x minus 3. And now I need to identify what is my y1. And my y1, I apologize for the barking, but my y1 is -1, and I'm going to plug that in lieu of y1. So I'll put -1 here. And the very last thing I want to do is I just want to simplify this. So I'm going to zoom out. And what I see here is that I have a double negative. I have y minus -1. And anytime we have those two negative signs right next door to each other like that, we're going to change it to plus. And so my final equation is y plus 1 equals -2 times the sum of x plus 6. All right, let's look at another example. All right, a really big thing we're going to have to be able to do is convert between our forms of equations. So we've been looking at point slope form today. And what we see this question asking is for us to convert to slope intercept form. So what I'm going to do first is I'm going to start by identifying what my slope is. Remember, slope is rise over run. So our rise, I see I would have to go down 4 units. 1, 2, 3, 4. So that's my rise. And my run is a positive 2 units. So I'm going to put that -4 over 2, which is going to simplify to just -2. Now I need to pick a point. I can pick any point. I'm going to pick 1, 2. Any point would work. I'm picking 1, 2. I'm going to label that the 1 is my x1 value and that my 2 is my y1 value. And now I can get ready to set up my equation. So I'm going to be taking y minus my y1, which was 2, and that's going to be equal to my slope, negative 2, times x minus my x1, which is 1. Now this is in point-slope form, but recall we want to convert this to slope-intercept form, right? We want this in y equals mx plus b form. So what we're going to do is we're going to solve to get y by itself. And to do that, we're always going to follow the same steps. The first thing we're going to do is we're going to distribute. All right, so the very first thing we're going to do is we're going to distribute this negative 2. So I'm going to take negative 2 times x, which is negative 2x. And I'm going to take negative 2 times negative 1, which leaves me with plus 1. Now I want to get rid of this constant. So I'm going to add 2 to both sides. And when I do that, I'm going to be left with y equals, my negative 2x stays the same, and 2 plus 2 is 4. All right, what I want to point out real quick is that we derived this equation using this line. We then converted the equation to get y equals negative 2x plus 4. And what Kansas really wants to make sure we remember is that even if we have a function in different forms, so here we drew a function, right? Here we wrote an equation of a function, and then we used it to convert. Even though these are all different forms, they still represent the same relationship that's happening.